All right, welcome to data distribution. So this is our statistics unit, and we are doing day one. We're going to be talking about box and whisker plots today. Learning goals. Okay, so all of this has to do with the box and whisker plot. You're going to be able to identify the median, interquartile range, and then determine true statements if you're given a box and whisker plot and a bunch of statements. All right, so let's go to how you can represent data. So statistical tools are used to quickly summarize and gain insight about a set of data, which is why labeling is important and doing everything properly. We're going to be learning about box and whisker plots today. Some important vocabulary, so I strongly suggest you write this down. All right, median. That is the middle value in a data set, not to be confused with mean or average. So if you list the numbers, it will be the one that's smack dab in the middle. Spread, that is when you take the greatest value of a data set and subtract the smallest value. That'll give you the spread. And then a quartile, probably one of the more important ones to remember. Actually, all of these are important. The quartiles of a ranked set of data values are the 3 points that divide the set into 4 equal groups, each group comprising of a quarter of the data. And then your interquartile range is the middle 2 quartiles, the middle 50% of a data set. All right, so if you take a look at a box and whisker plot, so here's kind of like you've got your Q1, which is your first quartile, and what that is right here is basically from your smallest value to, if you took the data and divided it up into 4 equal groups, that would be that one. From there to your median is also equal, and then from your median to your third quartile, and then your whisker, so you have 2 whiskers, your lower 25% and your upper 25% spread. Your interquartile range is this here from Q1 to Q3. So it's basically the middle 50% of the data. All right, so how box plots are constructed. Let's say we have a list of numbers. We would put them in order from smallest to largest, and unlike some of the other things we've done, we would repeat numbers. So like you notice that 7 shows up twice, we still count it twice. So the minimum would be 7. Maximum would be 29. The median, which is your middle number, would be 20, and it's median, not medium. And then your Q1 would be 14 and Q3 would be 26 because those are right in the middle. So you've got 4 on this side of it, 4 on this side, same over here. So for your lower end, you include the minimum, and for the upper end, you include the maximum as part of that number. All right, when you graphed that 20 would be the median right here. Your Q1 would be this right here. Your Q3 would be this, and then you would construct your whiskers. And it's important to label them too, so you're not just going off a number line. So let's take a look at the first example. We have manufacturers of MP3 player tracks. They're sold monthly in 2 stores. So these box and whisker plots show that. So we want to compare the median of the 2 data sets. Well, Lakeside Electronics has a median of 70, and Ortega has a median of 80, which is greater. Okay? Compare the spread of the 2 data sets. So this is where you take your maximum of, like if we look at Lakeside, it's 100 and the minimum of 40, and we're going to subtract the 2, which gives us our spread of 60. And then we do the same thing with Ortega. Also has a maximum value of 100, but has a minimum value of 30. So it has a spread of 70, which is greater. And then we would want to know what is the maximum value for Lakeside Electronics. Well, it's 100. It's the maximum value. Next example. We have data here on branches of biology. We want to know which branch has the largest third quartile. So you got to be careful with the wording of this. If it says like Q3, that would be like, what is the maximum? It would ask, which has the highest Q3 or the highest third quartile. We want to know which has the largest third quartile, which is this whole range in here. All right, so if we look at these, just by looking at it, we can eliminate a bunch right off the bat. This one's gone, this one's gone, this one's gone. So now you got to look at these two because they have about the same place there, but this one scoots just a bit above the line. So molecular biology would have a spread of 6. And then which branch has the largest interquartile range? So now we're looking at the entire middle 50%. And this is where it might help to do a little bit of subtraction. And then again, with this, it's a little bit harder. But here we have, so if this is 10, then we would have, this one has a spread of 14. We can tell by looking at it that these aren't going to be the case. So again, we're looking at this versus this. And botany would have, oh, sorry, not 14, 12, would have the largest spread with 12. All right. And then last example, based on the box and whisker plot, which of the following statements are true? All right, the median income for nuclear engineers is greater than the income of all musicians. So we're saying median income of nuclear engineers is greater than the income of all musicians, which unfortunately, that goes right there. So while they do have a higher median income than musicians, we're talking about all musicians. So anything beyond this point is higher than that median, so that statement would be false. All right, we look at the next one. Musicians have the largest interquartile range. Looking at the size of the boxes in the interquartile range, yes, that one is absolutely true. But we're going to go ahead and we're going to look at the rest too in case there's more than one that's true. All nuclear engineers earn more than all police officers. Well, nuclear engineers falls into this area. Police officers, this area. So no, not all of them do. If that was some nuclear engineers, then sure. All nuclear engineers? No. A musician will always earn more than a police officer. While it does go quite beyond what a police officer does, let's say we had a police officer here and a musician here, or even a police officer on the lower end, that would not be true because a musician could earn less. And then nuclear engineers have the lowest income. You can see that that is not true because their lowest part is here while the other ones have lower ones. Their minimums are much lower than a nuclear engineer. So that one is also not true. So again, no real computations involved here, just a matter of reading data and being able to understand the vocabulary that's being used. So that's why I said it's important that you write that down. All right, so that does it for box and whisker plots for this first target, and hopefully you understand everything, and if you don't, please ask questions in class. That's it. Thank you.